Hey scholars, we are about to start a new unit on polygons and quadrilaterals. So this is going to be the first lesson of this unit, and we're going to just kind of introduce polygons and learn about their characteristics and properties, and then we're going to build on that the rest of the unit. So make sure you're taking good notes and following along. Let's get going. Alright, so let's talk about what a polygon actually is. A polygon is a closed figure that's formed by three or more segments that only intersect at their endpoints. So it needs to fit all those criteria. It needs to be a closed figure, it needs to be formed by three or more segments, and those segments can only intersect at their endpoints. We call each segment a side, as we've talked about when we've discussed triangles. You know, triangles have three sides, three segments that come together. A vertex is where the segments meet. It's the common endpoint of the segments, or of the sides. The diagonal of a polygon. It's a segment that connects any two non-consecutive vertices. What I mean by non-consecutive, well, let's talk about what a consecutive vertex is. Consecutive vertices would be as you're going around the polygon. So look at this. This is 1, 2, 3, 4, 5. That's an octagon. So as we go around this octagon, so here's one vertex and here's the next vertex. Well, since these vertices are right next to each other, then we would call them consecutive vertices. And consecutive vertices are on the same side as we have here. But if I skip that vertex and put a point right here at that vertex and I connect them, we call this a diagonal. These are non-consecutive vertices. Or I could have a diagonal from here to here as well. So any vertex to a non-consecutive vertex would form a diagonal. I could also have another diagonal here, or from here to here. So there are three diagonals right there, and actually just formed a triangle. But anyway, so that's what a diagonal is. So here are some examples of polygons. All right, they fit that criteria. They fit the closed figure formed by three or more segments that only intersect at their endpoints criteria. Here's some non-examples of polygons. The reason this is not a polygon is that these segments right here and here, so these segments, they do not intersect at the endpoints. They intersect at a point in between the endpoints. Okay. Now we could break this off right here, and we'd have two triangles, but this entire figure itself is not a polygon. Okay. So look at the next example. The problem with this is that we have little rounded edges here. We cannot have any curves on that polygon. Okay. There are no points, there are no true endpoints here, okay, because of those curves. So that's not a polygon. And then this one's obviously not a polygon because it is not closed. If we close this, then it looks like that one, or at least really similar to that one. But because it is open and it's not closed, this is not a polygon. So we name polygons by their number of sides. Now, you might want to make a note of this. The number of sides is equal to the number of angles. So the number of sides is going to be equal to the number of angles. So a triangle has three sides, right? It also has three angles, triangle. So here's some types of polygons. We have triangles, quadrilaterals, pentagons, hexagons. Well, triangle has three sides. Quadrilateral has four sides. Pentagon has five sides. Hexagon has six sides. Heptagon has seven sides. Octagon has eight sides. Nonagon has nine sides. Decagon has 10 sides. So those are listed here as well. We also have a 12-sided polygon would be a dodecagon. For some of these, you might have some tricks or some ways of remembering them. Obviously, we know what triangles are. Quadrilaterals, quad means four sides. Skip over to octagon. Octopus, that's eight. They have 8 legs, right? So octagon has 8 sides. Nonagon is 9 sides. I think about like nineagon. I don't know, that might be silly to you. And then you got decagon and dodecagon. If decagon is 10 and dodecagon is 12, I think of do like dose. So Dos, like meaning 2, and then decagon, well, 2 plus 10, that's 12. I don't know, those are some tricks that may or may not be helpful for you, but those are some ways I think about them. Now you see right here we have n, number of sides. N-gon. So what does that mean? Well, we could say n equals, I don't know, we're missing 11, right? We skipped from 10 to 12, so 11. We don't have a word for 11, an 11-sided polygon, although that can be a thing. So what we would call that would be an 11-gon. Or anything above 12, you could have a 13-gon, a 15-gon, a 20-gon, a million-gon. Okay? So n can be any number, and you would just say that number, gon. All right, so let's try this. We want to tell whether each figure is a polygon. If it is a polygon, we want to name it by its number of sides. Okay, well, this is definitely a polygon. It fits the criteria that we mentioned earlier. It has 1, 2, 3, 4, 5 sides, so this is a pentagon. So this is a pentagon. All right, so that is a polygon. It's a pentagon. Part B looks like an example we saw earlier. It is not a polygon. Not a polygon, part B. C. Well, that is a polygon. All right, it's closed, no rounded parts. Its sides meet at the end points. So let's see. Let's figure out what its name is. Well, it has 1, 2, 3. It could help you to like put a little mark. Now these look like congruent tick marks, but I'm not saying they are congruent. I'm just using them to count off to make sure I've already counted for that side. So 1, 2, 3, 4, 5, 6, 7, 8. Oh, that's 8 sides. Well, that is an octagon. Again, don't be confused. I just use that to help me count. That does not mean that these sides are congruent. And I just erase that. All right. Now let's look at some more. Let's see if we can identify these. Well, this one, part A, definitely not a polygon because it's open. B, let's see. That definitely is a polygon. I'm going to count the sides. 1, 2, I'm going to put those little marks there. 3, 4, 5, 6, 7, 8, 9. Okay, so that's 9 sides. I have 9 marks on there. So that's a nonagon. Like I said, ninagon. It's a nonagon. All right, and this one is not because we have that curve right there. So not. And one thing I want to mention, if we have a circle, is that a polygon? No, that's a circle, not a polygon, because the whole thing is round, right? So a circle is not a polygon. It's just what it is. It's a circle. All right, so let's move forward. So let's talk about regular and irregular polygons. So a regular polygon is a polygon that is both equiangular and equilateral. If a polygon is not regular, then it is irregular. All right, so if it's not equilateral and equiangular, then we would just say it's irregular. So here's some examples of regular and irregular polygons. So for a triangle, all the sides are congruent, all the angles are congruent. Here are examples of regular triangles: quadrilaterals, pentagon, hexagon, octagon. So they are equilateral, meaning all their sides are the same length, and they are equiangular, meaning their angles are all the same measure. They're congruent in measure. All right, so here's some examples of irregular. These are not equilateral or equiangular. Okay? So let's go ahead and move on. All right, so another feature of polygons is that they can be concave or convex. They are concave if any part caves in. Okay? This says if any part of the diagonal contains points in the exterior of the polygon. Now that's a fancy way of just saying it looks like it caves in. So here's an example of concave, a concave polygon. See how it looks like it dents in or it caves in? So concave. If it doesn't cave in, then we consider it convex. Okay, so here's an example of a convex polygon. It's not caving in. So regular polygons will always be convex. They will not cave in at all. So that's a feature of regular polygons. So let's try this. Let's tell whether each polygon is regular or irregular, and if it is concave or convex. Well, look at part A. We have a quadrilateral, which is a rectangle. We'll talk more about rectangles in future lessons, but this is a rectangle. Is it regular or irregular? Concave or convex? Well, for it to be regular, it has to be both equilateral and equiangular. Now, the rectangle, all of the angles are 90 degrees, so it is equiangular, but it's not equilateral. See, you have the long sides, all right, and then you have the shorter sides. Well, the short sides are congruent to each other, and the long sides are congruent to each other, but not all the sides are congruent, so it's not equilateral. So this is not regular, therefore it is irregular, but it doesn't cave in. It doesn't cave in at all, so we'd say it's convex. All right, now let's look at B. So what we have here is, let's see, it has 1, 2, 3, 4, 5, 6 sides, so this is a hexagon. Let's see, it is equilateral, all the sides are the same length, and we see that it's equiangular. All the angles are the same measure. So this is a regular hexagon, and because it is regular, it is definitely convex. Remember, all regular polygons are convex. They will not cave in. All right, so now let's look at C. Well, this is definitely convex. I noticed that right off the bat because we see 4 parts of it that cave in. Right here, right here, right here, right here. It looks like 4 dents. If it is concave, it cannot be regular. So this is definitely irregular, concave, and it is also a, let's see, how many sides does it have? 1, 2, 3, 4, 5, 6, 7, 8. It is an octagon. So it's an irregular, concave octagon. So I hope this lesson was helpful for you. Make sure you study those names of the polygons and make sure you're able to identify convex, concave, regular, irregular, etc. Come to class prepared to work. Good job today. Thank you, Collegiate Scholars.